Hello and welcome to another episode of Astronomy Answered Simply. I'm your host, John Dodesky. I'm an amateur astronomer for many years, overall space enthusiast and lover of science and learning. Today's question is one that I find particularly interesting because it brings to mind all sorts of thoughts and ideas about what is out there in the universe. So let's dive right in. What method has successfully detected the most exoplanets? Exoplanets are planets in other solar systems outside of our own solar system, beyond Earth, Mars, Venus, Jupiter, Saturn, Uranus, Neptune, Pluto, etc. So Mercury. So when we look at other stars in the sky, other star systems, there's 5 different methods that can be used to discover planets. So the most successful method is the transiting one, where you have the light from the star, represented by my phone here, and something passes in front of it, temporarily dimming the light from the star. Usually it takes a couple of orbits for that to happen, so sometimes it takes a long time to confirm discoveries. Sometimes it's very quick because some planets have orbital periods of just a few days. But according to the NASA website, exoplanet website, which I'll have the link in the Quora article, in the Quora answer, there have been 3,261 confirmed exoplanets discovered via the transit method. 820 planets have been discovered via radial velocity. And what does the radial velocity mean? So let's take this little baby toy and pretend this is our sun. Well, we all think that Earth moves just like this. But in reality, all planets, and I'm removing this and switching to a couple of bottles that I happen to have near. I really should grab some balls to do this. But so if you have a large mass like our sun and a smaller mass like our Earth, the sun is at the center of the solar system, but as the sun orbits, it pulls ever so slightly on the sun, and the sun pulls ever so slightly, or much more strongly, on the Earth. But we can see that little wobble as the sun, or the Earth, orbits the sun. Now it gets more complicated when you have multiple planets pulling in different directions, but all of that effect is measurable with accurate enough instruments over time. And that's one of the reasons it takes so long to discover exoplanets, is because it takes time. So the reality is we think it goes like this, but there's a little bit of give and take and pull and tug between the planets. And planets and stars actually orbit what's called a common barycenter, which is the actual gravitational center. The gravitational center of our solar system is not the center of the sun. It's actually close to the outer edge or just near the surface of the sun, because that's the common center that all the planets and gravity, because you have large planets like Jupiter and Saturn out in the solar system that do tug back and forth with the sun. So one of these days I'll answer a question about gravity, because it's the most misunderstood concept of physics. Other ways we have discovered exoplanets. So we've talked about radial velocity, we've talked about the transit method, direct imaging. We can actually have taken pictures of other solar systems where we can see the planets because of the orientation. Instead of us being edge on, they're like this, and we can see actual planets reflectivity by blocking out the star and seeing the light from the reflected off the planet from other stars. Another way is gravitational microlensing. This one's rare, fairly rare, but light in a gravity lens. Gravity lens, okay. Gravitational lensing is we can see the image of the planet on a far side of a heavy gravity object, like a star. So let's say you are there, and here's the star. And it's a very large, massive star, and it's shining very brightly on a planet fairly close to it. Well, when it hits, the light from that planet hits just the right angle in respect to us, the observer, or in this case, you could, the gravity, the light reflecting off this will be warped by the gravity so much that you can actually see an image of the planet around the star. It's more common and easier to discern these things with a black hole because the light from the star isn't obscuring the light from the reflected light off the planet. But it is possible because we have instruments where it will image a star directly and it will have a blot to block out the light from the star and then pick up any gravitationally microlensed light that comes around the star. Really fascinating stuff and really complicated physics and math involved in that. Again, not going into that because this is Astronomy Answered Simply. The last one is astrometry, which is minuscule movements, which is I'm trying to figure out what the difference between that and radial velocity. Oh, right. Okay. So radial, the five methods, astrometry and radial velocity are very, very similar. Radial velocity, you can actually, we observe the changes in wavelength of a star as it and the planet orbit a common barycenter, and we can pick up like a red shift and a blue shift as the light is coming towards us or moving away from us. The astrometry is the actually just detecting those movements and the wobble of the stars, not necessarily via redshift or blue shift, but in relation to other stars nearby that are more stable, or from background stars or background pulsars that are far away. Typically, it's just in the relationship of near the star. Again, look at the NASA exoplanet link in the Quora article that I've put, because it does a great job of having graphics, and I'm not reinventing the wheel. We've already paid for that with our taxpayer dollars at NASA. That's why I love NASA. So those are the five methods, and again, the most common is the transit. And the interesting thing about the transit method is, in order for us to actually see the detect exoplanets that way, the edge, or the you think of our solar system with the sun in the center and the planets orbiting around it, the ecliptic plane has to be, the planet has to pass in front of the star and be in line with Earth so that we can observe it. So if we can't discover exoplanets, if, let's say, here's Earth and it's tilted this way and the planet's orbiting like that, we'll never see the planet pass in front of the star relative to us, because it's inclined, the orbital plane is inclined at the wrong angle. So when you think about that, that's why we have other ways to discover planets. But when you think about that, there could be all sorts of orientations of planets and stars, and we think planets are extremely common. Right now, we suspect most planets, most stars have planets. So that's it for this episode. The basic methods of finding an exoplanet, and the most common being the transit method. It's the easiest to discover, requires time and just, big light bucket over time. Thank you very much. Like, subscribe, send me questions via Facebook, YouTube, Quora, however. And have a great day.